Hello, I'm Luca and this is the Web3 in Travel podcast, where you can learn about crypto, blockchain, and how the new internet will change travel. Today, we will talk about fees. Fees are something which does not exist in Web2, but which is really important in Web3. Another primitive, if you want to define it like this, something which is at the base of everything when we deal with blockchains. So what is a fee? A fee is basically money you pay every time you do a transaction. And doing a transaction means writing something on the blockchain. If you write something in the blockchain, you're actually asking the whole network to replicate it on thousands of different computers and to keep it there basically forever. It's a very big step. It's like writing something in stone forever. And that's why it tends to cost a lot compared to simply writing something on one server in Web2. But let's start from what we know. Let's start from Web2. So suppose you are doing an operation, a transaction on Web2 website. Maybe you are uploading some pictures in booking.com, or maybe you are confirming a reservation in Airbnb. When you do this operation, you do not see booking.com or Airbnb charging you for this specific operation. There's no clear, explicit cost for it, but there is a implicit cost. So the moment you are confirming a reservation on Airbnb, something happens on Airbnb servers. You are consuming electricity, resources, space, even bandwidth. So it actually costs money to record your confirmation. So how much money does it cost to them? Well, it's really, really little. It's probably 0.00, many zeros, and then 1 for that simple confirmation. Even in aggregate, if you try to see how much every operation you've done on their servers in the last year, it probably doesn't amount to much. Maybe, 10 cents of a dollar, I have no idea, but basically nothing. But for them, server costs in general are pretty high. So they have to keep millions of transactions a day happening. They have to pay for servers. They have to pay for people who take care of the servers, and et cetera, et cetera. So they have high costs for that. But still, they decide not to charge the customers for the specific transaction. This is a behavior which is all over Web2, and it's obviously the only behavior which could have done, because it's really hard to calculate the cost of a specific transaction. So what Web2 companies do is they charge us in different ways, and in the price they charge us, they include this specific cost. Now, in case of OTAs, online travel agencies like Booking.com, Airbnb, Expedia, and others, the price is in the commission. So they charge a commission for every booking. And if it costs, $100 for that booking, those $100 cover very well the specific cost of the transactions which compose the reservation. Other companies like Facebook and other social networks, they don't charge us at all, but they make money out of our data and advertisement. Google does with the same thing. So basically, Web2 is organized in a way in which we are not charged directly for transaction costs, for server costs, but we are charged in general for the service. Now, Web3 works differently, very, very much. Web3, first of all, there's no company. When you are interacting with the Ethereum network and you write a transaction, there's no company which can charge you. There is no, as I was saying, Ethereum Inc. somewhere in a skyscraper in New York. It's a network made of miners, people who are running these computers, and they charge you for the transaction. Let's say that you want to send some ETH, which is the currency of Ethereum, some Ether, again, Ether is the currency, ETH is the ticker, is the symbol. So you want to send some Ether to somebody else, you will see that there's a gas fee, which is basically how much you have to pay the network for this transaction. And let's say that the gas fee is $5. You send the Ether, the whole blockchain updates to your transaction. So they take your transactions and they add it to the blockchain. And you pay the miners who made this possible. They keep the network running and they keep it secure. So what we accomplished in Web3 is to be able to get a service, which is servers basically, without a centralized company. This is something which is a bit, difficult to grasp at first, and I was explaining this in the previous podcast, but it's a bit like when we used to send letters through the post office, then email came as a protocol, and now we don't need any centralized company anymore to deliver our letters, and everything is more efficient and faster. Now, Web3 is not about efficiency and speed at all. It's all about decentralization, which basically means it's all about removing intermediaries. So writing on the blockchain is much more expensive than writing on one company's website. And that reminds us this very important aspect. Decentralization is expensive. It is less efficient in the same way as democracy is less efficient, more expensive and slower than dictatorship in a way, right? So when you have to reach consensus rather than having one person decide, it is always slower and more expensive. Another way to see this is to consider the blockchain, let's say the Ethereum network, as a mega world global computer, which is made of many thousands of computers and which, again, doesn't charge you anything else other than the cost of the transactions. So when you are billed by Booking.com, you're 15-18% on every booking. A very small part of it is due to cost for server. When you are charged $5 by Ethereum network to send some ETH, you are charged the cost of a transaction. And there's nothing else. There's no other service there. It's just riding on this enormous computer, which is going to keep your transaction there no matter what for the foreseeable future. So you may wonder, why am I going to spend all this money rather than simply doing this with a centralized company? Let's see, for instance, about money. When you're sending some Bitcoin, you pay the Bitcoin fee. Let's say it's $1, $5, $10, depending on how congested the network is. And the other person will receive it, and that's it. It's a very simple transaction, which basically is going to happen for sure, and you can send it and don't worry about anything else. When you are using centralized services like you're using a bank or Western Union, etc., yes, it is sometimes faster, sometimes it's cheaper, sometimes not, but anyway. But you have a lot of dependencies. It's not simply a money transaction you're doing here. You are basically adhering to a set of rules set by these banks. So, for instance, they could say, okay, before we send this wire, let me know and tell me why you're sending it, to whom, what's your justification. Sometimes they may forbid you to send it to some places. Like, I don't know, you cannot send wires to Iran because they are out of the SWIFT network. And many things. They could also call you and say, look, we still need to verify your ID again. Why don't you come? And then some people, sometimes happens you have to get your car, go to the bank and present them with a piece of paper, and then your account is unblocked again. So this is not to say what is better and what is worse, but just to say that when you are sending Bitcoin, you are using a native function of the internet for sending money, and you simply send the money. That's it. There's no other consequences. When you're using centralized services, you are part of something much more complex, which can be sometimes better, sometimes worse, but it's completely different. You are not using a native feature of the internet. Again, it's like sending a letter or an email, basically. And in general, when you have a centralized alternative which works, it's really hard to grasp why should you use a decentralized one, which is not working that well, which is slower and more expensive. It gets really interesting when you do something online on the blockchain, which is impossible to do with centralized services. But we're going to get to that later on. Today, we're going to speak about the fees. So, what do the fees buy? Well, they buy a very scarce and important resource, which is block space. Again, let's go back to Bitcoin. Every 10 minutes in Bitcoin, a block is created and it can contain a certain number of transactions. If there are more transactions which want to get in that block, some will get in, some will not. And it's the decision on which one gets in is about how much fee they're going to pay. So there's an open market for block space. The same thing happens in Ethereum and basically in every blockchain. So people are fighting and they are bidding for space in the next block. So if you are in a hurry, you pay more. If you can wait, you pay less. I tried to give you a visual of a blockchain, and the best one I found so far is a train. Okay, there's a number of carriages. Let's say that you are a person and you want to get on this train. There's a carriage which is about to leave, and it costs you $10 to get on that one. And then there's another one which is leaving a few minutes later. In case of Bitcoin, is 10 minutes later. In case of Ethereum, is a few seconds later. But anyway, it costs less, $9. If you are not in a hurry, maybe you can go to a carriage which is leaving much later, and you are going to pay $1. So one thing to remember is that this price changes all the time, because you may get on the first carriage for $10, and then a lot of people come in and they are ready to pay 11, and you're basically kicked out and you are downgraded to another carriage. So it's basically like a market for space on the train. Okay, it's like a train where there's, if you've ever been to, let's say, India, and you go to Mumbai in the railway station, there are these trains which are really, really full. And there's more people than space, right? And in India, it just works that the first which arrives gets the space, which is what happens basically in trains in general. The blockchain is more like a low cost in a little bit. It's like the price is dynamic, a low cost airline. I mean, so the price is dynamic. If there's a lot of demand, the price goes up. And the difference with a low cost airline is that once you have your ticket on the low cost airline, you, even if you paid a little bit, you still get to fly. In the blockchains, you can lose your space if somebody comes later and wants to pay more. So it's dynamic, but even more dynamic in that sense. This brings us to a very important concept, which is often lost even to people in crypto. The fees are the result of market forces. There's no evil blockchain owner who decides that today fees are going to be expensive. The fees are basically defined by the market. We define those fees. So when I go and I try to make an exchange between Ether and, let's say, USDT, and the fee for doing that is $30, if I do not accept this fee and I say, okay, I'm going to do it tomorrow or another day, I am contributing to the fee going down. If, on the other hand, I want to do that exchange and I pay $30, well, I'm contributing to the fees going up. There's a lot of complaining in Web3 about high fees, especially often by people who actually pay them. And this is just to remember that it's basically out of the hand of anybody. There's a certain amount of block space and there's a certain demand. And by the very basic law of demand and offer, the price is defined in the most transparent way. So let's get to the sticky point, the point where everybody is always complaining about, which is especially the Ethereum fees. So Ethereum fees are, in this moment, in this last year, have been extremely high. So let me give you a few examples. The cheapest operation is sending ETH. ETH is a native currency. The execution of the smart contract is not taking too many resources. It costs about $10 to send some ETH. So if I have to send you $10 of ETH, I'm going to spend actually 20. To send tokens, this is more expensive because they are smart contracts that are more complicated. It costs about $30. I'm talking about prices I see right now as we speak. Sometimes they go higher, sometimes they go lower. Uniswap swap, which basically means exchanging tokens, it's about $87. Now, you understand very well that this is not sustainable for a lot of operations. Again, if I have to send you $10, it's not worth. If I have to send you $100, it is not worth. It's 10%. But if I have to send you one ETH, which is about $4,000, well, maybe it's interesting, especially if I'm comparing to sending you a international wire transfer, which sometimes is $30. If I have to send $100,000, well, the fee is really low. If I have to send you $1 billion, well, that's great. Imagine sending $1 billion to a bank, where is often there's a fee in percentage. There's no percentage here. There's just the cost of the transaction. And so the higher we go in value, the less is the percent. So up to a certain value, the percent is very, very high. And over that value, it gets lower and lower. So it is really expensive for some use cases, and it is incredibly cheap for other use cases. Now, most people do not move $100,000 or $1 million, right? And most people actually today in Web3 tend not to have that kind of money. The feeling is that it is too expensive. But I've just demonstrated with these examples, it is expensive depending on what you do. In some cases, it is really, really cheap. Now, why can't Ethereum make it cheaper? That's another important aspect. It is easy to make a cheap blockchain where one transaction costs you 1 cent, tenth of a cent, a thousandth of a cent, or basically nothing. This is pretty easy. What you do is you do a blockchain, but you keep it centralized. It means you don't have 1,000 or 2,000 or 3,000 nodes, which can run on, let's say, normal computers. But you have, for instance, 10 nodes, which you control or you and your friends control. This is more like a federation, right? And which can run on very powerful computers like servers. Another easy way to get a cheap blockchain is to have less demand than offer. And this is pretty common in many new blockchains. So once in a while, a new blockchain comes out and says, we are faster and cheaper than Ethereum. And mostly it's because people are not using them. So if you have this train with 100 places and there's 50 people who want to get on the train, it's going to be cheap. Many of these blockchains, they attract users because they are cheap, but as soon as users become more than the space, the prices go up, the fees go up. So the market says, for instance, that it is worth spending $100 on Ethereum for minting a very expensive NFT. The market also says, no, I'm not going to spend that money for playing a video game or for buying a very cheap NFT. I'm going to use another blockchain. Basically, if you look at every blockchain and at the price for a transaction, you can see how much the market values that specific blockchain. That doesn't mean the market is right. They may be paying too much on Ethereum, or they may be paying too little on another blockchain, not understanding the trade-offs with security. But it gives us an idea, basically, of how much the market values each specific blockchain. So if we see blockchains as sellers of block space, then we have the premium space. Let's see it like real estate. So Ethereum is considered as prime real estate. Other blockchains are cheaper. They are considered more in the outskirts or not in a city. So what is the right thing to do? Should you use Ethereum or should you use other blockchains? There's no clear answer here. It really depends on you. It depends on what you're doing, why you're doing it, and how much value there is on top. So let's say you are starting now, you want to experiment with Web3. Do not touch Ethereum. It doesn't make any sense. You will spend a lot of money for basically nothing. let's say that after a few months, you see that there's a very interesting NFT project, and it's running only on Ethereum, and they are probably running on Ethereum because they expect to have a high value in the future. They want to be 100% sure it's, for instance, censorship resistant. And you may decide to spend your $30, $50, $100 for minting that NFT. But again, this kind of decision shouldn't be taken at the beginning. It should be taken when you have a more like deeper knowledge of the space. For experimenting, it's much better to use blockchains like XDAI, where one transaction is thousands of a dollar, Polygon, where it's also very low, maybe the BSC chain, which is in about 10, 20, 30, 50 cents of a dollar, so it's much, much more expensive. But there are things there which are not present in others, and Phantom is another one. So there's really many of them. And just to give you an idea, if you want to experiment with DeFi, I would suggest you XDAI. If you want to experiment with NFTs, I would go with Polygon. And more recently, Solana seems to have a growing NFT ecosystem. Solana is also pretty cheap. It is a multi-chain world today. So we're going into the direction where every app is going to be connected to different blockchains, and you will choose the blockchain you prefer. So again, if you're starting, don't go on Ethereum. Just go on Ethereum when you want to do something which is not possible elsewhere or which is of high value to you. In terms of airdrops, which I mentioned in another episode, Ethereum seems still to be the best one. That's where most of the airdrops are done. Like a couple of weeks ago, there was a big airdrop for ENS domains, which gave people a few $1,000s, $10,000, $15,000. The price varies, but it was a very good one. And and that happens on Ethereum because ENS domains is basically the ICANN, so the domain registry for Ethereum domain names, and that happens on Ethereum because they need, when you buy a domain like this, you want it to be there in 5 years' time, 10 years' time, 20 years' time. So you spend more gas, but you feel that you are more protected with your property. And the fee system works basically in the same way anywhere. So when you connect your MetaMask to any of these blockchains, and before doing a transaction, you see how much the gas is going to be, and then you accept it or you increase it if you want to be faster. And that's it. It doesn't really change in terms of learning how to operate with them. So if you learn, let's say, on Polygon, you're going to be good to go on Ethereum. The only difference would be the absolute price in dollar terms. So where is this all going? Well, it looks like, we don't know. Everything is moving really fast, but it looks like that Ethereum is going to be the final settlement layer for finance because it's the safest one. So basically all the operations done by the retail, so us, are going to be on other blockchains or on layer 2s, and we're going to get to layer 2s later. And on the Ethereum network, we won't write anymore. It's only, companies and protocols and then people who settle thousands of transactions in one go will write there. So we are slowly getting out of the era in which people wrote directly to layer 1, and we're going into more a layer 2 or sidechain future. To explain this without these novel terms, which probably you've never heard, it's a bit like what happens with credit cards. So when you pay with a credit card and it's done in less than a second, you are simply writing on a database. But this is not settled yet. Your bank doesn't know it yet. So it takes some time for Visa to accumulate and aggregate all these transactions and then send them to the banking system. So the banking system, in a way, is the layer 1. You do not write to your bank every time you pay with a credit card or the debit card at the supermarket, right? You use a layer 2, which is Visa. That's a bit the same thing. So are fees in Ethereum going to go down? Probably not that much. I mean, as long as there is demand, as long as the demand outstrips the offer, the space, the price is going to be higher, right? So Ethereum has been working toward scalability for many years, and it is progressing. We have layer twos now, which allows us to operate in a cheaper and faster environment, and we don't touch the Ethereum layer one anymore. There are many other blockchains which allow us to do things which we cannot do on Ethereum. Ethereum itself is going to do something called the merge next year, which basically means stopping proof of work and going to proof of stake, which basically means it's cheaper to keep the network secure. It remains to be seen if it's actually secure or not. There's debate also around that, but they are going in that direction. And after that, it should get cheaper also at the layer one. The thing is, you cannot really say how much the layer one will cost. What you can say is that how many transactions the layer one can hold. So if today Ethereum can hold a certain amount of passengers on the train, and in the future it will be able to manage 10 times, 100 times, or 1,000 times more, this doesn't mean the price will go down, because if there's a million more requests and passengers, then the prices will not go down. And since it seems a constant that in computing there's always more demand than offer, I think we can safely foresee the fact that the Ethereum network is never going to be cheap. And one thing is for sure, it's never going to be very cheap. Let me tell you what happens with Polygon, for instance. So Polygon is a very cheap alternative to Ethereum. You can do NFTs there, and it's suffering spam. Now people are minting NFTs, and they are sending these NFTs to other wallets just to make it like a spam, like, oh, look at my NFT, why don't you buy one? And that's because the transaction fee is really low. So there is no way a blockchain can have zero fees or almost zero fees without incurring in spam. So again, it's another trade-off. You want to make it cheap, you have to be ready to deal with spam. So presumably there's always going to be costs to write on the blockchain. We just don't know how much, but a minimum cost is going to be there, at least to reduce the worst kind of spam. There's actually an interesting concept here. You know email spam, right? You get all these millions of email spam messages. Why do you get them? Because it costs nothing to send an email. As I was saying, it's not nothing. The transactional cost is a fraction of a cent, is basically nothing. But to send a million emails doesn't cost much. Now, imagine if sending an email costs 1 cent. You would still send them, because you send 100 emails a day, it's still $1. It's not too much, right? But if I'm a spammer who sends a billion emails a day, well, then I have a significant cost, and I'm going to have to either spend the money, make it worth, have a better return on investment, or send less emails. A very interesting thing is that in the email protocol, at the beginning, there was this idea called proof of work, if I'm not mistaken, in which before sending an email, the software had to do some kind of computation to prove some amount of work, exactly because spam was going to be a problem. Now, this has never been implemented. Spam is being dealt by centralized services like Google and others through a variety of systems which detect spam messages. But it's interesting to see that the networks without any cost tend to be overwhelmed by very low or negative value transactions. So again, blockchains will always cost a bit of money. The point here is, will the cost be more or less than the value it brings to me? So to have a rough idea of the whole situation, you basically have Ethereum, which is really expensive. Then you have Bitcoin, which tends to be not too expensive, but you can do much with Bitcoin. This is the whole Web3 doesn't touch Bitcoin. Bitcoin is its own thing, right? And then you have all the other blockchains where the gas fees usually are not a problem. You don't even look at them. So when you have to deal with Ethereum, fees are a problem. Now, is there ways to mitigate the problem? I would say yes. So let's say you need to do a transaction and you're not in a hurry. So what you say is like, okay, how much is it now? Now is $100. I'm ready to pay $60 maximum for this one. I won't pay more. So what you do, you start your transaction at $60 and you launch it, and then you wait. It may take an hour, it may take a day, it may take 3 days, it may take a week. And it's going to go through only when the gas fee goes down. This is a bit more technical because you actually don't define the value in dollars, you define the value in GWEI, GWEI. That's the name of the unit of account for gas fees, and you see how it gets a bit complicated. The other way is to do it when the fees are low. So sometimes you see them go down and you do your transaction. You keep a list of things you want to do, low gas fees list, and then when it goes down, you do it. And this requires you to be on the computer and be ready for when this happens. Usually it's the week in Europe, is the weekend in the morning. That's when I see this happening. But just to give an idea, it's not going very much low. If it's 100 during the week, you're lucky you can get it for 60, but more probably for 80. And here I'm talking about GWEI because, as I said, I told you, it depends on what you're doing, right? If you send Ether, is maybe $9 or $5. If you do an exchange transaction, it could be $100 or it could be $50. So it's measured in GWEI. In the last months, a not too bad price is 100 GWEI. Just to give you an idea, in January, I think, or sometime this year, we saw 10 GWEI or 20 GWEI, if I recollect correctly. And sometimes you get in and you see 500 GWEI or 1,000 GWEI. And that's what everybody in that moment is trying to do something. Maybe there's an important NFT drop or whatever, or the market is crashing, everybody's trying to sell or to buy. And so when you see those kind of numbers, you have to know they don't last too long, a few hours, maybe a day, and then they go down again. But in general, it's very unpredictable. Now you'll say, why don't protocols, companies, why don't they pay for us the fees in the same way as it happens in Web2? So I don't have to worry about this thing, right? And yeah, it happens. It happens because there's a thing called meta transaction, in which you do a transaction on a network, on a protocol, and you don't see gas fees because they are paid by the protocol itself. This happens often in Polygon, but this is pretty rare today because it's a bit risky for the protocol to pay your fees not knowing if they're going to be the same, it's going to be cheap forever or not. Sometimes they have these peaks. I think that in the future, we will hide the fees in general. We will not see them anymore. Maybe because we prepay them, maybe because we are charged for the service. Fees are very cumbersome in general. So I think we're gonna see a world in which we will not even look at the fees anymore in many protocols. This is early stages. You are on the frontier when you do these things, so it is still complicated. It's still annoying and cumbersome. It's of course going to get better, but there's also when the opportunity tends to be less interesting. So see all these difficulties as an opportunity, because most people, when they see those things, they just go away. And you don't want to be most people, right? You want to be amongst those who experiment and go on the frontier. So to recap, we pay fees because we pay a network and we don't need to pay an intermediary. Fees are expensive when there is more demand than offer of block space. Ethereum is very expensive because it's more decentralized than others, or at least the market gives value to this perceived or not decentralization. Another thing is that other blockchains are cheap because they're playing an easy game. It's easy to do a cheap blockchain. You just need to have few users or centralize it. And things are going to change in the future in Ethereum. We're going to see layer 2s all over in Ethereum and other blockchains. So things are basically getting better from a technical point of view. Blockchains are getting more powerful, more optimized, but we may not see that very clearly because demand is growing. More and more people want to use blockchains. And even if blockchains are faster, the feeling may be that they're still expensive. It's a little bit like when the internet was really slow and then we had broadband. And because we had broadband, then YouTube could be created. And because we had YouTube, we needed more broadband. So the 1 megabit we had, just acquired seemed very fast compared to the 56 kbyte we had with the modem before. And then YouTube comes and 1 megabit is not enough because it gets stuck, and then we get 10 megabits, and then we have Zoom, and then it's not enough. It's a never-ending race, right? So expect blockchains to be better and faster and cheaper in general for what we do on them, but they're never going to be cheap or very cheap, or if they are, it's because there's a trade-off. High fees in general mean that the market is ready to pay. So it's a healthy indication of a network. Going down with the price of the fees simply improves and increases the number of use cases. So we definitely need to get better fees, so cheaper fees, as long as we don't throw away decentralization. Because if you throw away decentralization, at the end of the day, why are we even using blockchains? We could use databases to do exactly the same thing, much, much faster. So let me give you like an extreme view. We could have a very, very fast and very, very cheap Ethereum network if it was run by very big data servers, data centers with servers running databases. It would be, instead of $100, would be 1 billionth of a cent for the same thing, but then it's centralized. So why would we even be doing that? Does it mean that the future is decentralized? No, we're going to have the whole wide range of decentralization and price and speed. We will see everything, and it's fine. As with every technology, we have to know why we need it and what we're going to do with it, and then decide which blockchain to use for a specific use case. A way to explain that, which seems to work, is that let's say I buy an NFT for $1 on Polygon. The gas fees are very low. I pay $1. It's great. Polygon is not the most decentralized, or is not as decentralized as Ethereum. But then for some reason, this NFT is worth $1 million. What are you gonna do? Well, in that case, if it's possible and if it makes sense, you move it to the Ethereum network. Because at that point, spending $100 for securing it is not a big deal anymore. Okay, so this is a bit the idea. So that's all for fees. I know this is not the most exciting subject, but it had to be done. Now you know this primitive and we are ready to go on. All right, this is the end of today's episode. I really hope you enjoyed it. For more insights on Web3, follow me on Twitter @tripluca, TRIPLUCA, and see you next time.